Hello, wait a minute, just wait a minute. I am connecting. I'm looking if my stream is live. Just wait a minute. Okay. Let me share my link of stream to myself to check if I'm live. Okay. Let me check once again. Let me check once again. Okay, so we are live. Okay, let's start then. Okay, yesterday in the session we had discussed that we will discuss the components of models. We were till here. Okay. Okay, we have scaled and normalized the data. Now was the part of model training. Okay, now comes the part of the model training, and I already explained you some of the architecture of the model: input layer, hidden layer, output layer. Now once we are done here, now we will discuss each things of the model. First of all, see, I'm not going to discuss everything here. I'm not going to talk very much in the live stream. The sole reason I'm doing this live stream is just for the purpose of my productivity, so that I can actually force myself to do task. So let's get started. Okay, so we have the code here for model building. Okay, I guess the best practice here is first again I'm doing this, importing the libraries at the top of the running it. Okay, we are done it. Okay, it's running. Never mind. Now we have defined a function build FCNN, that is build a fully connected neural network. Take input shape as a parameter. Then we are defining the architecture of it. It has one hidden layer, two hidden layers, and one output layer. And the activation function of the output layer is sigmoid, and the hidden layer is ReLU. Then we are using optimizer as Adam optimizer, and binary cross entropy for the calculating the loss, and accuracy for the evaluation metrics. And then we will compile the model. Okay, okay, that's it. Now let me just follow. We'll work around these things. Okay, now let's see. Okay, running this. Okay, I successfully ran the here. So as in the hidden layer 1 there are the 64 neuron. In hidden layer 2 there are 32, and the dense layer that consists of one neuron, that is the output neuron. Okay, so for anyone doesn't have, I'll just see this. Okay, what I'll do is, I'll just take this code and I'll just explain it. For someone who doesn't know, I'm really sorry. I'll just say explain Adam binary binary cross entropy. Okay, and what do you else, and a batch normalization as well. Okay, so for anyone wondering what is sequential means, it is like a stack of layer in a sequential format, and a stack of layer as we are stacking here layers. First one is input layer, then a two hidden layer, then output layer. So Adam optimizer. So Adam stands for adaptive movement estimation. It's an optimization algorithm used to update network weights iteratively during training. It combines ADAS from two other optimization algorithms: ADAGRAD, which adapts the learning rate for each parameter, or RMS prop, which also adapts the learning rate but with a different mechanism. Adam is popular because it generally works well in practice, is computationally efficient, and requires little memory. Okay, so basically it's an optimize gradient descent. Okay, so during the back propagation we update the weights. So Adam optimizer helps in finding the optimal weights. Okay, optimal weights and bias the parameters. And then another parameter, that learning rate, you can search that yourself. Learning rate is basically, if learning rate is too small, it will take time to converge. No, sorry, it takes time to learn the model, as because the steps taken by the learning rate are very small. If learning rate is too big, it misses the some intricate details. Then then based upon that trial and error mechanism, we find which learning rate is beneficial. Then binary cross entropy is basically measure the difference between the actual minus predicted. And batch normalization is a technique used to standardize the input layer by recentering and rescaling them. Okay, so that's it is. Now dropout basically means deactivating some amount of neurons. Okay, now once we have built the model, we have 64 and we are trying to we are using Bayesian normalization in both the hidden layer and dropout in both the hidden layer. We'll work around this. Okay, and then we'll just take it. Okay, now train the model. This is model.fill. Now we are training for 50 epochs and each epoch contains 32. Okay, and use a small okay, and we are using small for a validation as well. Now I don't know what verbose means. Let me just see what is verbose. What is verbose? Okay, so we are using 50 epochs. We will verbose parameter model control the verbosity of the training. It determines how much information is displayed during the training process. Silent mode. Now output is printing verbose one. Progress bar. Okay. So for progress, so we are fitting the model. We are training it for 50 epochs. Okay, and each epoch has 32. So 32 into 50. That is 30 into 50. That is 1,500 total sample, I guess. And okay. It's 2123. 2123. Shape is 2123, I guess. I don't know how that works. Okay, let's see. It's training now. Oh my god, it's accuracy is 95. Already the accuracy is very high. Yeah. Okay, the accuracy is our validation loss, is it decreasing? If it's decreasing, then we can further increase the epochs, number of epochs. Okay, it's decreasing here, decreasing. Last 10 epochs, we'll see. Last 10 increase, decrease, increase, decrease. Okay, validation split is equal to, so 95% accuracy we are getting after training for 50 epochs, and 95 0.95%. And according to that research paper here, if I'm not wrong, the accuracy is 0.977. Okay, that is 97%. How can, okay, can we increase the number of epochs? So if we, okay, what should we do here? What should be our, yeah, okay, got it. Now we will just finally will generate a prediction on test and calculate the testing the key metric suggested by the researcher from SQL and import classification report. So again, I'll just import this at the top. Generate probability prediction. Why pred probability? Why what? I'll just copy this once again and I'll explain you. Why pred probability basically means we are using a testing here, something called testing already. Okay, y probability is equal to model.predict on x test scale dataset and convert probability to binary result where and print the benchmark score. We'll just see. Okay, precision 97, recall 97. Okay, accuracy 97%. Okay, so we are f1 score is 0.93, mcc is equal to, we'll just look at that offset dataset for now. Precision is 96, 96.3, 920. mcc is 93, 932, 930. Okay, 991, 91 is for our, in our case it's 0.91, 91%. Now classification report, we are printing the y test. Okay, precision, recall, f1 score. Okay, I guess it's already more than enough for predicting anomalies. Okay, we are right. Next, in this code we use a fixed threshold. However, inside you might want to adjust this. If you want to catch every person high recall, you will really, okay, high recall, lower the threshold. If you want to minimize false alarm, okay, but in, I guess in satellite operation, high recall should be prioritized more than a false alarm. Okay, so you can, I'll just use it 0.4. Where is that thing? I'll use the threshold 0.4. Then we'll just see. Hey, okay, 9143 recall precision. Okay, 0.4 is seems good. The see the I guess I want to plot the chart of how the validation loss. Okay, let's plot the chart of validation loss best. I'll say, how do I plot the chart of validation loss? And what is the, yeah, validation loss? Okay, model is equal to model is equal. Okay, we'll just say except. So again, once again, taking all the inputs. We'll import the matplotlib at the top itself. Okay, and then we're using what are we, I'm hiding this. Okay, training loss is equal to history dot validation loss history dot. Okay, the training loss and the word epoch is equal to, and then plt dot figure. Okay, we'll just see. Okay, this is the training loss, this is the validation loss. We can see validation loss is decreasing, I guess. Validation loss is being constant. I think we can train the model more, I guess, for 65 epochs. Let's check for the model for 60 epochs, right? Then we'll plot the model. 96, 97, 96, 96. Okay. Okay, MFCC is increased. Now let's start the plot the graph. Okay. What can we infer from this graph? Actually, let me just see what can we infer from this graph actually. Okay, the model is overfitting. Okay, so I guess that was a wrong method. We shouldn't do that. Back to our 50 epochs. I don't want the accuracy metric, just what I'm saying. Good. Now we'll get some scores low, but it's okay. And now what? Again, train the same model. Okay, there's a fluctuation actually. Means what the fuck? Why is the graph different from the earlier? Why is it fluctuating so much? Are we retraining it or something? Are we? I guess it's storing the history. Because there's no way, right? Highly fluctuating. The validation loss is highly fluctuating. It shouldn't be have that one. Why is this taking so long? Okay, so okay, so we need to this again, and then we need to 65 again. Okay, now I guess it's good. Now let's see. So that's wrong. We need to okay, so we need to return the build fcnn function. I'm not wrong. And now we'll see the graph. Okay, 9317, good. Good. The graph is good, I guess. The graphic is good. 9317, and according to that data set, it was 93 9317 932. Okay, it's fairly near. And precision 963. Micro average, weighted average, fun score, precision in antidote. Okay, I guess this is good. MCC f1 square is 9455. f1 score is 9455. Okay, this is good actually. This is actually good. Yeah, I guess this is good. Now the graph is not overfitting. We can see there are some inconsistent spikes. We'll copy this and now go it to the, but this is far better than the previous one. It's telling me that you should apply early stopping. Okay, I guess we should apply early stopping then. So early stopping basically means stopping the training of the model when there are very minimal changes in the weights and biases, and it's telling that around 40 to 45 epochs the model is already trained. There is no need to run, no severe overfitting. Okay, the overfitting is there, but it's slightly there, over here, but I guess it's fine. It's fine, I guess. 65 is good enough. Okay, we have built the model, I guess. We have built okay. We need to save it as well, but before that, uh, what can we do here? Let me add this input. Threshold, we have decided threshold to be 0.4. Okay, this is all done by is the stream. Okay, this is all done by manually, trial and error. I can do it. Okay. Okay, so this let me visualize this architecture. Okay, I want to visualize this architecture. I'll go back to, I'll duplicate the tab of the Gemini. I'll create a new chat. Let's see, new chat baby. Okay, what the fuck? Okay, so now we are loading Nanobanana now. This is actually where. What? That was fast. Okay. This is the Epsilon model architecture which he gave us, Jimmy. Now I'll run this same for Google, sorry, what is that called? ChatGPT. We have input layer, length of feature, and it's saying that the input layer, let's see, where is the input layer? Yeah, the input layer. And then there is a dense layer, which has the activation function rel. It has 64 unit and batch normal and 0.2% dropout. Then the shape of the input layer, that is 2000 something into 18 and something. And there is a hidden layer, then 32 units, batch normal dropout, and then okay. Now let's go back to our, what the fuck? Why is this hallucination? Okay, it's creating an image finally. Okay. We are 0.44 and 0.4 threshold. Okay. Still doing. Hmm. Hmm. Okay, now we have developed a model actually. Now we have to, you know, simulate a program for live data. The fuck is this? Input layer, input shape, input layer 1, features, age, salary. Well, there are no such features there, okay, but it's just saying hidden layer 1, 64 units, activation 0, batch number over 0, then layer 2, dense plus batch number dropper, regularization, input layer, activation function, okay. So nothing useful here. Okay. So what's next? I guess we'll need to save the model. We have built a model and I guess it's good enough to work, you know. We need to then merge together various components. Why is it giving me code again? For what's it telling me to do, man? Didn't we already um tells me we are scaling the data and it's telling me that you are ready to move path consider the next step is implement a robust training anywhere this universe using the fully trained coordination while ensuring that evaluation along with the standard defined behavior. Now staring to you doing the same thing. I'll just use the file. I'll download it as a .pub. It's telling me the preparation was intended to pro computer end-to-end script, so that the implementation has the. Okay, I guess so. I'll just upload the file. Fuck, bro. Okay. Implemented a neural network with regularization. Implemented a neural network with regularization based. More and assignment doesn't excel the threshold of payment. Currently, using hardware instead of operation, the cost of the full set of was issue implement operation is to find mathematical useful to plot trade off. Redundant is a better specialized was a universal detector worker. When he tries to learn all of the research papers, the special channel detector can sometimes perform better because of causal range of action. Filter rotated over single model. Compare reference bar. Feature important analysis. Following, I recommend with the operation reference why which is threaded. Let's go. Let's go with the precision recall curve. After taking the now we want to determine the threshold for it. Required efficiency volume dead like offset around 10 seconds around while accuracy and misleading as the model gets added just by guessing normal pair curve focus ratio in the model on the anomalies. How to improve manual pair curve. In a satellite operation, you often face it. You catch everything around, but you might trigger false around. Every alarm you trigger is almost relevant, but you might miss susceptible. Where implementing, you can add this snippet to your code anomaly to generate a curve and find the minimum optimal threshold. Okay, let me just do it. Here from scalar.matrix again. Just simple from scalar. Okay, we have calculated the precision recall for all threshold. Okay, calculate the average precision. Key benchmark. Find the threshold that maximizes. We add a small epsilon to our division by 0. Base index, base threshold, base F1 threshold. Okay, now let's get started. Base threshold is 0.330. Sweet spot is 0.30. Best F1 square possible is 0.95. Optimal threshold is 2.944. Okay, best threshold is 0.35. Sorry, 0.3. PR curve AP is equal to best F1 score is 95.96. So 0.4 is also an optimal, but 0.3. Okay, optimal threshold period or recall precision color is equal to blue, label is equal to PR curve average precision. Okay, base threshold is 0.3. So we'll need to train this FN and again just 0.3. I'm not going to use 0.3. I'm going to use 0.35 as well. Okay. Neuron is like the automated okay. In the research paper, the research sorted all their baseline results specifically and they are under curve. It enters the precision recall curve. This is because it tells you global quality of your model recursive threshold. Your AP is high. Your signature of no, AOC is very high now. What is our AOC? AOC 98%. Okay. 0%. What is the once we have this, we can use it and final improvement 0.3. 0.3 is the threshold. Okay, 0.3 is the new optimal threshold. See, now we are using the patient required threshold equal patient required code. That's what it probably number. I'm really sorry. Understand okay mode in the when you load the following high recall the model plus the model lower update the evaluation code. Okay. The research paper. Okay, now we'll update the enumeration code and I'm not going to 3. I'll going to use 3 point. You can just remember these thresholds. Let's call did I just cut the output? Okay, this is our threshold here before setting. Before the threshold, now we need to run this again and we need to do this again. Oh, there was no need to do that again. I'm very sorry. We'll use the threshold 3.5. Oh, I should have stopped at the 50th epoch, but never mind. Okay, hearing this set. Okay, now our MFCC is the new report. Let's see our new report. Our new precision is 98. 99, 94, 16, 1, 97, 94, 95, 113. Our F1 square is 955. It increase and our MCC also increase. Okay, what is the new F1 square? 9550. 9550. Okay, we have got a good one. If you recall, it's like, but you are if you're well, I'd say slightly higher than 9, but we are president of 0, you have created a safe model. President drop below. Okay, whoa. President never did drop below anything. Okay, so we'll just this is a better core actually. We'll just upload this actually to Google Gemini. This is actually unnecessary column, but we can do that. Okay, I guess we have built a model and now we don't need something extra like why this model is important and all. Okay, now I'm not going to prove that one. We have built an universal model for each anomaly. Okay, I guess we save the model now. Okay, I guess we should use the model and then we'll, because that's the important thing. Okay, now model. Okay, let's save the model. Okay, offset.keras. Now we can use that model. I'm not wrong. Yeah, download. We are using the keras actually, and I'm just again I'm going to file, save. Control C, major project, anomaly detection. Here we are, baby. And again downloads. Control C, major project, anomaly detection, model. Control V. Again, I'm really sorry. Control X, Control V. Anomaly detection model. Okay, Control S. And if I'll go and check if okay, let's refresh it. We have both models here. Now I'll git check out to my branch. Branch name, and that is, I'm not wrong, yes, ls. It already exists, so git branch. So if it's already exists, I need to change the branch, right? I'll use the branch this one. Yeah, just see the okay, new file. Yeah, git commit that model push, if I'm not wrong. Okay, now let's check if the changes are reflected in my GitHub. I want to check if I added my friend as a collaborator. Okay, I will check the letter. Okay, never mind. Okay, so we have successfully created the model and saved it. Now what I want to do is I want to create a simulation of the data which I have and pass it to that model, and so that it predicts it lively. I'm too tired now. Okay, I guess but I guess let me just check how much time it has been since the last testing. Each anomaly. Okay, I guess. Okay, we have 38 minutes. That's too low. I need to go on now. I'll explain my synopsis to the GitHub. Sorry, Gemini first. I'll upload my synopsis here and explain my project first. Major project synopsis, if I'm not wrong. First, I'll need to open if it's the correct synopsis. Why are the 3 tabs open, bro? Okay, if I'm not wrong, yeah, this is the synopsis is correct. Okay, first of all, this is the methodology, our project methodology. Telemetry data ingestion, historical satellite telemetry data is replayed in real time to simulate a live telemetry. We are just simulating it. We are not actually taking like feature saturation and temperature such as rolling, anomaly detection, knowledge graph mapping, LLM plus RAG abstraction, so user interface dashboard. So this is actually our we are not going to use LSTM autoencoder and isolation forest. That was very LSTM autoencoder was really very shit model as far as I know for this purpose, because LSTM autoencoder just basically reconstructs the input, and that's what it does. So what I have done so far we just created a model. Now we need to, what I need to do is live telemetry data ingestion and then predicting the anomaly detection. Okay, I mean, okay, I'm taking a break of 5 minutes. Okay, so till then, you can take a break as well. I'm taking a break of 5 minutes, and then I'll come back here. Okay. Okay, so I guess we had a break of 5 minutes. Let's start back. Now I'll upload my synopsis here. Upload the synopsis project to the Gemini. This one, yeah, open it. So I'll also upload the methodology. Where is the methodology? Yeah, because okay, let's start. Okay, I have uploaded the about project, which provides the overview of the project. Below is it below its methodology. Okay, so far we have built the model. Now we want to ingest or simulate the data lively in it, so it can make prediction on live basis. Okay, and then we come to the later part about mapping anomaly and explaining using element array. Okay, let's start. So yeah, this is the methodology. Now it takes very long time to actually understand how we will use this model. Again, I'm going to use Cola for it. I'm not going to do test it in my original file is located at this state. So you proof from static script to license. Remember, streaming simulation, your static data from segmented CSV will act as a live source. I replied, okay, so it's telling me that to use segment.csv, and but I guess we have trained the model on will act as live, so replied by 1 to 1 video, and then you must handle the transition from to 18 feature. This your model explains. You must handle the transition from raw data points to 18 feature vectors from a single point. The live simulation logic sliding windows. Since your epsilon model predicts on segment summary of rather than single value, your initial model must be a sliding window buffer. Okay, sliding window buffer. Okay, let's open the paint here again. Vector basics. What this actually means. We'll try to decrypt what this means. Okay, so transition from your static to live system as already in step 1. Telemetry data ingestion. You need to implement a streaming simulation. In this phase, your historical data from segment.csv will act as the live source, replied point by point to feed your model. Okay, as an AI ML engineer, you must handle the transition from raw data point to added feature your model expects. Okay, the live simulation, logic sliding windows. Okay, since your epsilon model predicts on segment summaries of behavior rather than single value, your ingestion model must have using a sliding window buffer. Let's do one row from a segment.csv at a time. Okay, so let's go back to our segment.csv. So we're reading one row from segment.csv at a time. Okay, and then accumulate this data points until you have enough to match a segment. Example 200 points. Okay, so it's telling us to define a segment. So for a 200 points, up to 200 points. Up to 200 till here. Okay. Every time a new point on or every second, you recalculate the 18 features for the current window. And the 18 features are scaled and passed to your saved keras model. Okay. But why are we using segment.csv when all the information is available in what I say a dataset.csv live ingestion, the script simulator. Okay, this is the live ingestion and prediction simulator. So again, I guess we are done with this. I'll just go with file. I'll go with the new notebook and drive. Yeah. Whew. I'll rename it to live. Live simulation on IPYNB. Let's connect this. Let's put this aside. Let's bring this forward. The script simulates the live dashboard experience by replaying your data. Data. Okay, now this is the code given by import pandas, import number, import time, import job leave, import answer, import collection, from collection import DQ, load your model. Okay, model is equal to, okay, we need to learn this. Okay, or either we need to upload the model here. I'll do that first. From the major project, we have anomaly detection, we have model, and we have, okay, uploading version 1. Okay, then scalar is equal to job lib.load scalar v version dot scalar v1 dot job lib, load the raw elementary source for replay. They simulate the segments where the historical data replayed in the raw data is equal to pd.csv. Set up a buffer, assuming an average segment length of 200 bytes. Start live training data, simulate training streaming for index.row in iterate simulates a zero point delay between telemetry time to sleep. Add a new telemetry point to the live buffer. Only predict once the buffer is full. Okay, now there is before doing this, actually I need to explain this actually. Even in dialog should trigger a data packet containing time when it happens and which association with why the model flagged. Allowed a print instead of print statement, you can leverage report data to create interview and knowledge. What will have to do? Okay, first of all, why did we use segments.csv instead of data set.csv on which our model was trained for live simulations? Okay, that's one doubt. We'll copy this. Very sorry, bro. Did he just give the code half? Okay, first we'll understand this code. Okay, now what did okay. If you use status.csv, you will feeding the model pre-calculated answers rather than testing your extraction knowledge, logic. Okay, but why why did you give why did you give code for only here? Okay, now let's go back to our ML inference pipeline simulation. I like this clearly system. Live telemetry streaming, real-time feature extraction, FSN and inference, anomaly alert triggering. This is what it's doing. Okay. Okay. Oh, decision. Okay. Already we didn't we decide the ratio. Hmm. Oh man, I'm very sleepy. we say we say something is wrong, I guess. It didn't import the job leave. It imported the job leave, but it didn't loaded it. Where is the raw data pointing at? Did we specify the path? Okay, actually, when did we save the scalar v1? We didn't save the scalar v1 as far as I know. Did we? No, we didn't. And there is nothing. Scalar v1. I'm feeling really sleepy, man. What should I do? I'm actually kind of blank right now. It's working, it's working, it's working. There are a lot of warnings here. I'll just see. How do I ignore the warnings here, man? I need to ignore the warning. We'll need to do something. It will import it and we'll need to accept and run. Right now, I don't have any idea what's being done here. I need to do this everything. I understand everything in detail as far as now. Except run it. Okay, we're running. What's staying doing the okay, I mean it's doing its work. Good, 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 good. When it's doing its work. Keyboard interrupt. Now score is it's assigning it's alert anomaly at okay channel 00. We'll actually see if this is true. Okay, we'll open our segment.csv. Yeah. Okay. Okay. Mm, okay, now we'll see if the channel is true or not. Okay. We have the channel. Well, if it's detecting, it's telling, hey, this is live animal, this is 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 animal, this is. The fuck are not anomalies there? Okay, channel is the entire channel anomaly? What the fuck? H72. Some are not. Okay, some are not. Okay, some are not anomalies. Okay, channel 872 score. Okay, I'll just start it. I'll just start it. And again, I'll let it run. Oh my god, bro. How is it understanding the inner implementation that this segment is anomalies? How is it calculating the mean variance, bro? I don't understand this. I need to ask the chat GPT, bro. Let me just full screen. Oh, the channel will be 873, then we'll stop this for now. We're ingesting the data live, but I don't know what's happening in the backend or the internally. The score, according to score, this is okay. Why is it stuck? It's stuck. How many total 872 channels are there, man? Am I kidding? $2,123. Okay. Ah, huh. Oh, let's wait till some other channel comes in. I don't know how long will that take, man. 2000 entries maybe. I don't know. Let's wait. Oh my god, how much entry does this model have, man? Like it's been now almost 8 minutes this model is being executed. Uh, Score is. Well, let's wait another minute, guys, and when the channel changes, actually waiting for which is not an anomaly. It's only or is it only detecting the anomalous set, right? I'm confused about that. Okay, 30 timestamp 40 15 20 20 20. Okay, it's detecting the timestamp 10 11 12 13. Okay, for each timestamp it's predicting it's an anomaly. Okay, now we'll check which timestamp it's not anomaly. Okay, let's go to our Excel sheet segment.csv and let's take this timestamp. Okay, so for now I'll just use this currently the executing one. $52 T actual label should be only anomaly. Okay, all 43 T32 1T 22 06 012 012 is over. Now it's going to 02T. Zero two 201 1 is to 17 1 is to 17 2 1 no 0 2 2 0 1 1 is to 17 1 is to 1 is to 17. Okay, 1 is to 17 is somewhere out there. Okay, let's see about the 18. There is nothing as a 1 is to 18 0 0 z. Okay, let's do 06. Okay, 02 T01. Okay, 18 18. There is nothing as 18 18 52 51 41 41 43 39 22 24. Oh, what is hey bro, why is it in 19? Okay, 19 19 is there. 21 20 21 20 28 30. From where the anomaly is not there, if it's not there, that is from 35. 35 should not be an anomaly. 31 is an anomaly. 33 is an anomaly. 34 is an anomaly. What the fuck? Anomaly add 35. 35 36. What the fuck is happening here? Okay, so I understood it right now. Okay. Okay, so I understood it right now. Okay. So it's telling me that
Okay, so I understood it.
so it's telling me that it's even it's saying that at considering the one total of 150 seconds, and in 150 second, even if there are 10-second anomaly, the entire window buffer will be flag anomalies. Okay, so I will ask a question. Okay. Okay. In your but I want out in this live streaming code there is only a probability is greater than session alert anomaly at. Okay, so let me ask him question. Okay, what if I create a data set of non anomaly and pass it to live streaming code? Okay, that's a great idea. It will ask me. That's a great idea. I know how this works. Create and pass it to the live streaming code. Okay, so pardon my mistake. Okay, man, this shit is exhausting, man. Whoa, why is it taking so fucking long? Ah, bro. Is my net not working or something? That is working fine. That is working fine. I'll again ask. Bro, why is this fucker? Man. Okay. Okay, now it's okay. Okay, it's saying that instead of seeing the alert message, you will consider like a remain quarter only print a heartbeat message if you added them. Okay, behavior stability program because the data in your buffer enter now there. Okay. So okay, so I'll pass the model. I'll now create a data set of the nominal. Okay, just wait, I'm getting a call. Hello. Room na. आपल्या घरी. घरी. काय ते ओम्याला माहित राव त्याला काय लावले. नाही आपल्याला पूर्ण सिनॉप्सिसचा प्ले काढूनच टाकायचं काहीतरी मॅडम. नाही परत गेलते की ओम्या गेलतो वाटते आज काय प्ले करायचं. हा प्लॅगरिझम नाही म्हणली 42% आता ती मला म्हणलंय की म्हणजे रिफ्रेश करून मला परत पाठव मी करतो परत चेक करायला जावं लागेल मग परत ती एनओसी असा विषय. ती प्लॅगरिझम काढ लावली ना बाकीच्यांना काय ना डायरेक्शन ऑफिस सबमिट करायला लावली आपल्याला म्हणली प्लॅग नाही आला पाहिजे. हा नाही मी विचारलेलं मॅडमने पण सांगितलेलं कुठल्या तरी. हा मग जर सिलेक्ट झाली तर जावं लागेल ना म्हणजे बघावं लागेल ते. नाही ती गोष्ट वेगळी. पण त्याला कॉपीराईटची स्लिप लागेल म्हणजे आपलं तसं बी होणारच नाही कारण आपलं कॉपीराईटची स्लिप येणार जर त्याच्या आधी झाला तरच येईल म्हणजे त्याला कॉपीराईट अप्रूव्हच नाही स्लिप यावं. हा ती साईन व्हायला 2-4 दिवस लागतात म्हणजे मला लई कमी चान्सेस आपले व्हायचे पण तरी पण झालं तर मग ते आपले एलिजिबल आहे प्रोजेक्ट म्हणजे किती कसं आहे आपल्यासाठी चांगलं आहे ते ऍक्च्युली. काय नाही म्हणजे ती टॉप टॉप जे प्रोजेक्ट आयडिया आहेत ना भारी भारी ती घेणार आहे आणि त्यांचं हे करणार आहे एव्हल्युशन असं काहीतरी. पण ते कधी कॉपीराईट वगैरे झालं मग जर आपला प्ले वगैरे रिमूव्ह झाला मॅडम कडनं तर मग होईल ते. बघू आता ते ओम्याला सांगितलंय मी ओम्याला कॉल करतो. जर रिव्ह्यू नसला तर याची काही गरज नाही पण बघू ना आता मग ते काय मेसेज टाकते तू तर म्हणला ते हाय आठवला. हा मग आपला एवढं लवकर नाही आपला नाही 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 लागा 2-3 दिवसात टाकते राव आधी रिव्ह्यू असल्यावर काय टेन्शन घेऊ नको. हा नाही नाही एवढं लवकर नाही 28 ला असायला बसलाय मी तुला फक्त सांगून ठेवले तरी पण मी मला परत व्हेरीफाय करायला लावतो. हा जाईल उद्या जाईल ना आता मला परत पहिला रिमूव्ह करून द्यावं लागेल. हो चालेल. हो चालेल हा चालेल. Okay, now I'll create a data set of nominal data and then pass it to it. So I'll see how actually it reacts. So what I'll do is I'll just create a, okay, I'll just filter. What I'll do is I'll just create, there is no filter should be here. Should be select all, okay. And then I'll just use sampling and label is equal to accept anomaly, everything. And now, okay. Count is 6840. I guess it's enough. And I'll create file. I'll create a new blank workbook. Okay, and okay, okay. Yeah, I guess we are good to go now. Good to go now. Control S, save as, browse. I'll just save it in download, and I'll just say comma separated. Test and all, test and all. I'll just say test and all. Okay. Now the anomaly 0 segment is equal to train. Okay. Now we'll just say okay. I'm really sorry. I guess I shouldn't include the training one because the model is trained on it. I should include only. I'm really sorry. Short fuck up, man. Not training for the testing. Okay. Again, let's go and place our thing. Fine. Okay. Test and save. Goodbye. I'll go back to our model and I'll just insert the test NA here. Upload the test NA. Not here. Live simulation. Upload test NA. Test NA. In the okay here and okay what the fuck did just happen? Test Anna is it loaded? Okay, is it test Anna raw data path. Okay, ready. Bro, what the hell? It's still telling me it's anomaly. It's not anomaly. There is no such thing. So
Why is it happening, man? What the fuck is steering, bro?
Okay, I'll do this. I guess I've done enough now. Okay, the model is silent now. For a short period of time, it was silent. Again, it is silent for 49. Okay, so it's good, man. It's predicting. It's not like again. It's we need to understand the internal details before building this shit, bro. This is complex thing. Never mind. I guess this is the live stream. We'll stop streaming now. I'll come back at later at night.
No, okay.
Live stream will stop streaming now.
What the fuck?
I'll come back at later at night.
No, okay.
Bye bye. Thank you. Take care. And don't forget to subscribe if you want to, join my journey. Bye.